Today we have a fantastic complex numbers question from the JEE Main 2026 January session. At first glance, this looks like a nightmare of modulus algebra. But wait, we are going to solve this using pure geometry, making it incredibly fast. Let's start with step 1, decoding the region S. We are given a strict inequality. 3 is less than or equal to the modulus of 2z minus 3 minus 3i, which is less than or equal to 7. To turn this into standard circle equations, we must make the coefficient of z exactly 1. Let's divide the entire inequality by 2. This gives us 3 by 2 is less than or equal to the modulus of z minus the quantity, 1.5 plus 1.5i, which is less than or equal to 7 by 2. Now, this is beautiful. This is the standard equation of a region between two concentric circles. Our center C is at the point 1.5, 1.5. The inner radius is 1.5, and the outer radius is 3.5. Let's draw this on our complex plane. Here is our center C, our inner circle, and our outer circle. The shaded blue annulus is our region S. Now for step 2, what exactly are we trying to minimize? We need the minimum value of the modulus of z plus the quantity 5 plus 3i divided by 2. In complex geometry, distance is always written as the modulus of z minus a point. Let's factor out a minus sign to rewrite this properly. This becomes the modulus of z minus the quantity minus 2.5 minus 1.5i. Geometrically, this is simply asking, what is the shortest distance from any point z inside our blue region to a fixed external point P at coordinates minus 2.5, minus 1.5. Let's plot point P on our graph. It's way down here in the third quadrant. Now, look at the diagram. You don't need calculus or heavy algebra here. If you are standing at point P and you want to walk to the blue region S taking the shortest possible path, where do you aim? You aim straight for the center. The shortest distance lies exactly along the straight line joining point P to the center C. The boundary of the blue region closest to P is where this line intersects the outer circle. Let's call that intersection point B. Therefore, our minimum distance is exactly the length of segment PB. Let's calculate this. Step 3. First, we use the standard distance formula to find the total distance from P to the center C. That is the square root of 1.5 minus 2.5 squared plus 1.5 minus 1.5 squared. This simplifies beautifully to the square root of 4 squared plus 3 squared, which is the square root of 25. So the distance PC is exactly 5. Now we know the outer radius of our circle. Let's call it r as 7 by 2, or 3.5. To find our minimum distance PB, we simply take the total distance to the center PC and subtract the outer radius. That gives us 5 minus 3.5, which is exactly 1.5. Converting that to a fraction, we get our final answer, 3 by 2. Looking at our options, option 2 is absolutely correct.